record this. I hope everybody has been able to find the videos on with the link. After every class, I'll upload a video of the session and post a link of it in the lessons piece. Yeah, unfortunately, Sakai changed the way that lessons thing, it used to be called modules, and then they changed it to lessons, and then changed the interface all around. So I'm I'm actually having some difficulty figuring out how to kind of do that, because what's happening is this one document that has all of the, where I put all the classes, is it just getting kind of big. And so in order to see what the latest one is, you have to scroll all the way to the bottom. As the class goes on, I mean, there are going to be roughly 30 or 40 classes there. So as the quarter goes on, you may just have to scroll way down. If I can figure out a way to reorganize it so that it's, I mean, the way I used to have it organized was kind of more in sections, but again, when they changed the interface, it wasn't, in my opinion, it wasn't well documented. So I'll, you know, you may have to do a lot of scrolling. Okay, so before I start, in terms of the concepts that I've been talking about, again, like toward the end of the class, I'll address issues regarding the latest assignment. But in terms of the lectures, are there any issues or questions or concerns about what I've been talking about and what the book has been talking about?
Just question on the public static. Is that so the only time we use that public static void with the strings and the arguments, that's in the main Java classes. Is that correct?
Well, so far that's the only place that we have used it.
Okay.
In fact, you can, I mean, as we gain more sophistication in how these classes are organized and what the objects are about, in fact, you can write a public static whatever method in any class. The question is it something that's appropriate? The way that I will often use it is for something called a factory method. Okay, I'm going to say some stuff, but this is just to answer the question. You know, so I'm not going to hold you responsible for it. But in the current assignment, I've asked you to kind of create an array of these single cards as an instance variable. Okay, so and that's kind of a fixed thing. There are other circumstances in which you'll have like a kind of container class that's that's going to hold a bunch of other objects, but well, and the thing is, you don't know how many there are going to be. Like in one application I'm working on, the actual number and data for these objects are in a database. So I read a table in the database, and that tells me how many objects I'm going to create. So I don't know that ahead of time. So one pattern that I use is every time I create it, I put it in a static container, and I have a method that will retrieve it from that static container. And all of those are static. So that would be like a public static list of these things. And so I'd have a method that would return those if somebody were asking for it. So does that, anyway, to make a short answer long, you can put a static method, and it is typically public in any class as needed. We haven't had a need for it yet. And we may not have a need for it in this class, but there is a need for it at some point. Or maybe need is a little strong. It's a useful thing. It isn't the only way to do it, but I found it to be a useful thing. Okay, so so today I'm hoping to peel back the hood a little bit on things that we've been doing. What, you know, I've been doing some things, and I've been asking you to do some things, and haven't really totally explained everything. So because Java is fairly complicated, or it's more complicated than the scripting languages that you may be used to, it takes kind of going over some of these things several times. So if there are things that are a little confusing, or if you're doing things and you're not quite understanding why or wherefore, then hopefully at some point it will all be explained, because my goal here is that everything that we cover, you have and everything that you do, you have a full understanding of. That's the goal. And I recognize that at this point, if you're not there yet, that's simply because we haven't gotten there. It's something fairly complicated. So so today, the three topics are, I'm going to talk about inheritance. We mentioned inheritance, subclassing, and we're going to talk about the fact that Java has something called single inheritance. Now, that implies there's something else called multiple inheritance. Java doesn't do that, so you don't have to worry about what that is. There's something called method overloading, and that's something that you're going to encounter in your next. Well, you've actually already done it, but I'm at a point, and you may not realize it. And then finally, how Java deals with constructors is kind of an important issue, and it's important to kind of understand what's going on there. Okay, single inheritance. Here's the thing which haven't been mentioned. Maybe the book has mentioned it at some point, but there is this, and the terminology is unfortunate. There is, we talked about classes and objects. So in contrast to the way that JavaScript does things, in Java, we create objects by first writing a class and then instantiating objects of that class. So we write a class, that class becomes the template, and then we stamp out as few or as many of those as we want by instantiating with the keyword new. That's something that we've already done with this single card. So single card is a class, it's a template, and I can create as many single cards as I want by simply saying new single card and giving it the information that it wants. Okay, so now and this is where things get confused. Notice the type. I've tried to put it in monotype. There is a class called object. Note the capital O. And I wish they'd chosen a different term. But object with a capital O, this is the name of a class in Java. And it's a class that every Java class subclasses. Your single card, even though you didn't say anything, was a subclass of object. The light class that I wrote was a subclass of object. Those shape classes were all subclasses of class object. Okay, so there's a class and there's an object, small o, which is an instance of that class. There's a class called object, of which all Java classes are a subclass. And this is actually in the PowerPoint I uploaded. This word was omitted inadvertently. this is what single inheritance is about. Each Java class can have only one immediate superclass. However, you can have, each Java class can have more than one subclass. We've seen that with the shape. I don't have it here, but if you look back a few classes, if you remember, there was a shape and there was a circle and a triangle and others. Those were all subclasses of the shape object, the shape class. The shape class, though, was a subclass of the object class. So in UML diagrams, it looks like this. The notation is this little open arrow. So this object class, again, UML has the name of the class. It has instance variables and instance methods. And so object has a constructor. This is its constructor. And then it also has a method called toString. And it has a whole bunch of other stuff. I left them out here. Object is actually a fairly large class. It has a whole bunch of stuff. But the two that are relevant to what I'm going to talk about today are these two things. One is the constructor. Every class has a constructor. That's another thing that we'll talk about with constructors. Every class has at least one constructor. And because every class is a subclass of toString, a subclass of object, because object has a method called toString, every object has a method called toString. Every class has a method called toString. So in this example, we have defined a class called pet. And even if we don't say anything about it, its subclass is object. Java does that automatically for us. We can make that explicit if we want, but there's really no need because it's understood. So in this case, my pet class has two instance variables, name and type. What I've defined here as well is and this isn't always done, but the constructor is also listed and its arguments are string and string. So what this says is when you instantiate a pet, you need to tell it you need to give it two strings. What do you think they would be? They would be the name and the type. It doesn't specify which order they are.
So if it doesn't have an argument in there, does it mean that you don't need an argument, or does it kind of give you the option to put one or not put one in?
Java is very strict about that. If there's which method are you referring to?
Well, so if you have string get name and that method there are no arguments that are listed as being passed in. Does that absolutely mean you do not pass arguments in, or is that just not listing them out and you may actually need them?
The first one. Java is very strict about this. If I define a method that has no arguments, then the only way that I can invoke that is without an argument.
Yeah, sir, I understand that, but I mean, like when you're drawing out this UML, is the UML that strict? Do you want, or is it like if you give us a UML and there's no argument listed, that means we should not be putting an argument in?
Yeah, I mean, UML, this is a way of just sort of showing what the structure of your class is without worrying about the code. In other words, I can write a UML diagram like this without, there's no code here. If I specify a method like this, then this is saying, if I want to be consistent with this, then my getName method must have no arguments in it. So in a way, this is a design document. And so if I write a getName that has something else in it in my class, I have not written to the design of the document. And that's, so what would be incorrect would be my implementation if I deviate from what the UML is. Okay, now the thing here, notice here that my pet class also has a toString. And just as we did in Light, and just as you did in single card, and just as you're going to do in the card deck, you write a different toString than the one that object provides. The one that object provides is just sort of if you've seen, it's a very generic one. What it does is it lists the name of the class, and then it says @ and then gives a bunch of gobbledygook. That's what it does. And one of the things about object-oriented programming like this is that if I write a subclass, I can write a different method of the same name and the same return type. And that will when it gets run, it will call that one. It will call, like if I print a pet instance, it will call this toString. Just as in your single card, if you print a single card, the system out print line and then give an instance of a card, it will call the toString of the single card that you defined. If you don't define a toString in single card, it'll print it'll print the one, it'll call the one in object. And in a later class, I'll go through in possibly excruciating detail what the Java virtual machine does when you try to invoke a method on it. Now, the thing about Java, because Java is a compiled language as well as an executable one, there are two kinds of errors that you get. One is actually the best error is the compile error. In NetBeans, you identify the compile error by the red squiggly, or sometimes called the red squiggly of death. So if there's a red squiggly under something, it means the compiler says there is no chance that this is ever going to work. No chance. So Java will not let you run the program if you have red squigglies, if there's a compile error. In other words, a Java program must compile correctly before it can even be run. And that's a good thing. That's a good thing, because that means that at least many, not all, but many errors can be identified before you even try to run the program. And it will help you by, at least the IDE will help you by identifying what those errors are. In contrast, think of a lengthy JavaScript program that runs for a long time, but then one piece of code that doesn't get executed until after it's run for a long time has an error in it. So what'll happen? Your program runs and runs and runs and runs, and all of a sudden it bombs out. Why? Well, because of maybe you fat-fingered some variable or something. Maybe it was a syntax error or something. Well, that's that's pretty frustrating. So that doesn't happen with Java, but Java provides other frustrations. So, okay, so I've kind of mentioned, this is called method overloading. That's the, well, I mean, it's just one term, and I think this is one of the terms that's actually pretty well defined. So method overloading is when you have more than one method with the same name. Okay, now what does that mean? In this case, it is the same name but different signature. So what's a signature? A signature is a list of the types of arguments. Okay, we've actually seen an example of that in print line, which we've used all the way going back to Hello World. So print line is written to be, it's overloaded. print line, in fact, is an instance method of a class called print stream. Again, you don't need to know that, but remember exactly what that is. However, kind of just, if you kind of keep that in your mind, the fact that this print line that we've been doing, that this is, oops, this should be a lowercase p. I don't know, your PowerPoint tends to kind of capitalize things if I don't, so this should be a lowercase p. Okay, so print line is you have a method of the same name, but 3 different, and there are actually others. There's one for floats and longs and, and objects. So each of these, if you look in the print stream class, each of these is defined as a separate method. And what happens when the virtual machine executes, so if I print line a string, it will call the method in print stream, which has been defined for a string. If I want to print an int, the virtual machine will go and execute the code in print line with a signature of int. And likewise for double, and likewise for all of the other different methods called print line. And again, that is called method overloading. And so methods of the same name in the same class, written in the same class, they must have a different signature. In other words, I can't have 2, for example, print stream cannot have 2 print lines that have an argument string. And that should sort of make sense. If let's say you're the virtual machine and you're running, and a class has written 2 print lines, the print stream class has 2 print line methods written, each of which with an argument string, and you encounter a print line of a string. Now, which code should you execute? There are 2 methods to go. I mean, there's no way to decide how to do that. So Java says, no, you can't do that. If I print line a string, it goes to that method and that method only. Okay, constructors. Now, again, we've been dealing with constructors. A constructor, it looks kind of like a method. It has the same name as the class. And so, for example, the class objects constructor is called object. In the case of my pet, see, the constructor was called pet. So the constructor is always the same name as the class. Now, it can have arguments, just like any other method. So, for example, the object constructor has no arguments. The pet constructor, it has 2 arguments. It has 2 strings. And so when I instantiate a pet, I have to give it 2 strings. And hopefully, based on how it's defined, one of those strings is going to be the name of the pet, and the other string is going to be the type, I don't know, cat, dog, cockatoo, hippo, whatever. Okay, so now here's the thing, is that Java requires every class to have a constructor. Every class must have a constructor. Now, if you've been sort of thinking about what we've done, you may have noticed that we have written classes in which no constructor was defined, and yet we were still able to instantiate it. So Java does something which, there are good reasons for this in a lot of ways. If you don't define a constructor in your class, Java inserts one for you. So Java says, hey, I see you forgot to write a constructor. That's cool. I'll stick one in for you. And I'm going to put a 0 argument constructor in you. Now, you can define more than one constructor. That is, constructors can be overloaded, but they must have different argument types. So for example, if for whatever reason I just wanted to define a pet without any type or any name, I could define a constructor and it say with just no arguments. Or let's say that I wanted to define a pet and only, let's say, only give it a type. I could define, in addition to that other constructor, I could define another constructor and just give it a string. So I could have all those 3 constructors there as long as they have different signatures. The constructor is what gets called when you say new. So when you say new, if I say new pet, then give it something here, then it will do, what it will do is it will call that constructor and execute whatever code is written in that constructor. So for the new card, for the single card, when you said new single card and you gave it an int and a string, that called the single card constructor that had an int and a string in its argument and executed that code. And what did that code do? In the case of single card, it simply set the value to the int that you passed in, and it set the suit to the string that you passed in. Okay, now here's the thing about a constructor. And this is a completely strict rule. This always is the case. The first executable statement in every constructor is one of 2 things. It's either a call to super or a call to this. Now notice that these are in typewriter case, which means that that's code. Let's see, are you gonna, okay. Now, this may be a little confusing because you say, we've never done that. You've never written either one of these calls. What Java does, and again, this is almost a Clippy let me help you with that. If you don't say super or this in a constructor, it will call super. It will insert super, a call to super for you. Now, what does that do? When you say super, it calls the constructor of the superclass. In other words, let's go back to our pet here. Let me clear some of this stuff out here. Come on. All right. Okay, when I call the constructor here, before it does anything, if I haven't written it, it will call super. It will call super. And what does super do? So it's the super. The call to super is just like that. What super refers to is the immediate superclass of a class. And super, in this case, will call the constructor of the superclass, in this case, the object constructor, before it does anything. And the reason for that is that that ensures that, you know, whatever initializations, whatever the object class needs to do to set up that object is done before any code that the user puts in gets executed. Now, oops. Where are we here? So the reason for the there will be a time when you get very confusing a very confusing message from NetBeans about this, because it'll complain about an argument mismatch to a constructor. I forget the exact message, but what's confusing about it is because you haven't written any code at all. And it happens, let's see, where are we here? So if I were to subclass pet and not write a constructor, I would get a compile error, because it would say that so let's say I have a subclass of pet called dog. And as I'm writing, you know, so I write dog, and I say, well, I haven't written a constructor yet, but NetBeans is giving me the squiggly of death. Why? Because what it has done, so let's say I have a dog. Here's my dog subclass. And I'm still writing it, and it's going to subclass pet. Okay, before I write the constructor, it's going to complain. Why? Because here's what happens. If I don't write a constructor, it puts one in for me with 0 arguments. Okay, that's not a problem. But then it says, oh, I see you have a 0 argument constructor, but you haven't written a call to this or super. So I'm going to put that in for you. I'm going to put in a call to super for you. It's going to put in a call to super. But what it always puts in, super, that's an R. Okay, sorry, it's not very good with this pen here. Come on. Super. Okay. So what does a call to super do? It calls the constructor of the superclass, pet. But now I'm calling a constructor with no arguments, but it requires 2 arguments. And so that's a compile error. Okay, so at some point this will probably come up for you, and it will. And if it's confusing at the time, kind of try to remember what I've just said. In other words, Java has put in constructor stuff for you that doesn't work. Okay, now just for completeness, there's in a later class I'll go through what this is about. This is one of the worst named things in Java, unfortunately, and they use this because C++ used this, and they wanted C++ programmers to feel comfortable, but it's a terrible name. Super is a good name because it's clear it refers to the superclass. And in fact, whenever you want to call a superclass method, you would call it using super dot method. Again, we'll see an example of that at some point. Okay, so any questions about what I've just covered? Okay, oops, close this here.
So if I understand it correctly, like if you don't specify what constructor you want to use when you instantiate a subclass, then Java is just going to look to the parent or look to the super and then just automatically try to use their constructor.
Well, almost. What Java will do, if I don't write a constructor, Java will write one for me. And then it will call it, it will insert the super with no arguments. So, I mean, so what you said was like 90% correct, but what it does is it first writes the constructor and then calls super and then puts a super in. That will work with no errors if there is a class, if there's a constructor in the super class that has no arguments, then there's no problem with that. We've seen that with object. That works if I write a subclass, if I just write a new class, and I don't need a constructor. I mean, usually you need a constructor, but if for whatever reason I don't have a constructor, there's no error. But what Java is doing under the hood is putting a constructor in for me and putting in a call to super, which calls the object constructor, the constructor in the object class, which has no arguments. So that's no error. But again, in the case of the, for example, if you were to subclass single card, remember the constructor for single card requires an int and a string. And if I were to subclass that, then I would have to have at least one of the constructors, in fact, all of my constructors, when they call super, would have to give it an int and a string as well. And we'll see an example of it. We'll see that in at some point. Okay, did that answer the question?
That makes sense. Thank you, sir.
Okay.
And when you're doing this, you have to pass something into that method to assign to this. Like you can't just use a variable that's already in the class. Like for single card, we did this dot suit equals suit, even though suit was I don't think it's not instantiated when you do private string suit, but it's
the call to this instead of super is a little different. Again, the call to this would happen before any of that. And you only use this in cases where you have more than one constructor. In other words, a call to this, as I'm using it here, would call another constructor. And if there is no other constructor, then it's an error. In the single card, the this there was referring to the object that you were instantiating. So when I said this dot suit equals suit, this dot suit was the instance variable, and the suit that was passed in was just the plain one. Did that land, or did that not make sense?
I think sort of. I'm not. There's a little disconnect.
Yeah, we'll keep coming back to how it has to do with how variables and methods are referenced. I mean, how do you? And I mean, I can say it very simply. All methods are invoked in the same way. All methods. In fact, let me try with a whiteboard here. All methods are invoked the same way, with an object dot method. Everything. So when you, well, all instance methods are invoked the same way. So, however, when you're inside a class, you can kind of leave the reference to the object that you're actually in is this. And so if I'm referring to an instance variable, the full name is this dot variable. If I want to call inside of a class, if I want to invoke a method, it would be this dot the method. But in order to sort of save the typing on that, I don't have to say this every time. The way to distinguish it, and NetBeans actually kind of helps you out here, because in instance variables are in green. And if I see a variable in black, a variable name in black, that means it's either a local variable or an argument and not the instance variable. Okay, so I wanted to okay, I got some messages to the effect that there was some concern about what I asked you to do. Okay, let me see that this is okay. All right, this is I think I pushed this up, so this is kind of my solution to the previous assignment. For some of you, there was some I guess there seemed to be some question about how to get started on this. What to, so to that end, well, okay, here's what I'm asking you to do. I'm asking you to create, okay, let me sort of stop this and see what we're about here. Okay, so the issue is this. Okay, so here's a task that you should be able to do, and that is, given a UML diagram, write a class, at least the structure of a class that matches that UML diagram. Okay, so the UML diagram in question here is to write a class called card deck. It has two instance variables. One is an array of single cards called my cards, and the other is a variable called generator of type random. It specifies 5 methods, one called create new deck, shuffle deck, get a getter from my cards, get card, which will return a card of a particular index, and then a toString to override it.
Was constructor left off just because it's a given, or is that inadvertent?
Well, in this case, the constructor happened to be left off because it was an empty constructor. I probably should have put it in. So again, if you don't put it in, Java will add one for you that does nothing. In this particular case, I believe let me point out here that, see what I say, the preferred, the random and the single card array, they say they're objects, they need to be instantiated, and it says the preferred location for this is the constructor. So what does that tell you about what your constructor should do?
This part confused me because when I was trying to do the first test, like I built the constructor and I was trying to figure out, does it need variables? Does it not? I mean, does it need arguments passed into it? And you don't really have any arguments to pass into it from the test, but I didn't know how to, I didn't know if this dot sync my cards and this dot generator would instantiate anything if it wasn't passed in.
Okay, well, let me ask you this. How do you instantiate an object?
How I did it was
No, not how do you do, how, just in general, how do you instantiate an object?
Is it like you could do it through this my card equals my cards?
Okay, does that instantiate anything?
No.
That's an assignment statement.
Yeah.
So how do you instantiate an object? Just in general, how do you instantiate an object? There's only one way.
Private, and then the type, and then the variable, and the name.
No, that's declaring an object, a class. That's declaring a variable. How do you instantiate an object? There's only one way.
I don't remember right now.
But when we use the word new?
Yes.
Okay.
That's the only way you instantiate an object, whether it's an array or some other object. The keyword is new. Whenever I say new and then give it the right thing, then that will instantiate something. Yeah, thank you. So, yeah, so that's, it's important to kind of separate all these concepts. So I declare a variable by giving it the type and the name. I assign a variable using an equal sign with a variable on the left and the value I'm assigning it to on the right. I instantiate an object by using new. So if it's a regular old object, I say new and then give it the name. If it's an array, I say new and give it the type of the array, bracket, and the quantity. So,
Sir, to further Brian's question, for that constructor then, would we not need to pass it any arguments?
correct.
Okay, thank
If
you.
all you're doing is instantiate, if there's no information that your class needs, then there's nothing to pass in. In other words, this deck is going to have 52 cards and it's going to have an instance of this random thing. And so there's nothing I need to pass in. Now, if I let's say for whatever reason I wanted my card deck to create different kinds of card decks. So for if you ask your great grandparents, there's a game called Pinochle. I don't know, you probably never even heard of it, but ask your great grandparent. My grandparents used to play it a lot. I played it only once and it was, I couldn't figure it out. The game of Pinochle has 48 cards and it has 2 of each kind. That's different than your standard card deck. If that's the case, if I wanted my card deck to do one of those things, then I would have to kind of pass into the constructor some information about that. One way might be is instead of instantiating my card array inside the class, I would have to pass it in, say. Okay, but we're not doing that. Here, this is just going to be one standard deck of cards. So there's nothing to pass in.
So in that example you just gave, is that similar to the first assignment where we were passing in all the information to the constructor and making individual cards?
Correct. Yes. Yeah. Very, very.
It's like we're just making a blank array, and then the function create new deck. That's what's passing in the information to single card, which then gets recorded in my deck, my cards.
Yeah, well, the idea is that create new deck would simply simply instantiate the 52 cards as you did in your test class for single card. In other words, in create new deck would have that nested for loop. And I would recommend that you not instantiate a new array, but simply assign because the array has already been instantiated in the constructor. So create new deck would have the same code as you had in your test class for single card. In other words, you would instantiate all 52 cards and assign them to my cards in the right order. Let's see, we unfortunately ran out of time. If you have a few minutes, I could at least show you how to start the class. Would that be helpful, or do you have to get to? Does everybody have to get to another class though?
We have one. I mean, but if guys, if they want to jump off because they gotta go do something real quick, it'd be useful to see it if you have a moment.
Okay, I'll try to I'll try to just sort of get it set up for you a little bit because that's okay. So I'm going to go fairly fast. So okay, how do you get started? Well, okay, UML says I want a card deck. Okay, so I create a new Java class called card deck. Okay, now the next thing to do is, again, this is right from the UML. And the only thing different is I need to make sure it's private. And all of this is just copied from the UML. Okay, now here I get a red squiggly. It says cannot find symbol. When you get that cannot find symbol, there are two possibilities. One is I either fat fingered it the way I just did with single card, or it needs to be imported. And the way to do that is I just click somewhere, say fix imports, and it imports it for me. No more red squiggly. Okay, so that's, now again, just kind of, okay, so this will, okay. So that's what it should do. So this, if you remember in test single card, what did you do? You instantiated an array and you populated it with the right thing. So here is where you would put that similar code, except now you're going to be assigning it to my cards. And so if you want to make sure that that happens, I can say in my constructor, I can either put this in here or I can make sure that somebody else does it. Okay.
I got a question, like with the public card deck, where you have underneath it this.my cards.
Yep.
Do we need that?
What? do I need this?
I guess from line 20 to line 23. I didn't have that, my code and all, but it was still working. That's like the whole constructor, isn't it?
Well, if you don't have that, then my cards is going to be null. And so you must be instantiating it somewhere else. If you never have this call, then this will be null. And if you never have this, then generator will be null. And every time you try to use it, you're going to get a null pointer exception.
Yeah, I just have my cards equals new single card 52.
You left this out?
I did, yeah.
Yeah. Well, that's what I was just saying before, is that that's optional. When you're in the method, when you're in the class, you can either, and you're referring to a variable that's in the class, you can leave this off. Sorry, I misunderstood what you said. In other words, this, you can leave this off, and that's fine.
We use this only when we're passing in variables.
You need it only if you're passing in a variable of the same name.
Okay.
In other words, see, for single card, see, here's something called suit. And you see how it's in black? Whereas the green one, now I have to say this equals suit. So if I leave this out, then what's happened is, notice it's saying it's assigning it to itself. So the only reason for this is to have the this in here is because they're the same name. If I change the name, and well, there are several schools of thought on this. I personally like this to do it the same name because it makes it clear what I want to assign to it. Okay, so for card deck though, again, they're optional because there's no ambiguity. There's no local variable. Okay.